Assalamualaikum and hello everyone. Thank you for listening to the recorded lecture here. Before we proceed our discussion on BJT AC analysis, I would like to do some revision with you on DC analysis, right? Last time we have learned about fixed bias circuit, emitter stabilizer bias circuit, and voltage divider bias circuit. These three are the common circuit configurations related with the BJT DC analysis. In fixed bias circuit, okay, we have this. The configuration will be like this. We have plus VCC connected to RC and RB, and there's no resistor at E terminal. Alright, each time when you want to do the KVL at input loop and KVL at output loop, okay, it is a good practice if you write down the plus VCE and plus VBE. Okay, so when you solve KVL at input loop, you will get the IB value, and then when you solve the KVL at output loop, you will gain the VCE value. At the same time, right, the DCLL or DC load line analysis can be obtained via or using KVL at output loop. If you recall my lecture, my first lecture in YouTube, okay, the DCLL can be obtained from the KVL equation, in which you can obtain CE value at x-axis and IC value at y-axis. Okay. So tips number 1, you need to remember or at least know how to obtain the DCLL. Okay. Okay. Next is the emitter stabilizer bias circuit. Okay. In emitter stabilizer bias circuit, we add additional RE. Okay, at E terminal. So instead of having only RB and RC in fixed bias circuit, we have another resistor RE. Again, please write down the plus VCE and plus VBE. Okay, so that each time you do the KVL, you don't miss them out in your calculation. The same thing, KVL at input loop and KVL at output loop, and DCLL can only be obtained from the KVL output loop. Now, for the third one, the voltage divider bias circuit, we have two methods to use, either approximate analysis or exact analysis. Which one to choose? Okay, you need to test the condition first. What I mean by testing the condition is that you need to calculate the beta RE. Beta is given in the question, usually is given in the question. RE also given in the question. So you just need to times them up and obtain the beta RE value. And then you calculate the 10 times R2. Alright, this is R2. Cannot see this one clearly here. Okay. So this one you need to remember beta RE, this condition, beta RE, is it greater or less than 10 R2? So if you find out that beta RE is greater than 10 R2, so you need to use approximate analysis. Otherwise, if the value is too small or smaller than 10R2, you need to use exact analysis. In this analysis, you have to apply the Thevenin method. Once you obtain the beta RE value, for example, greater than 10R2, so you know you need to use approximate analysis. So refer to important note at input section. So input section is over here. In approximate analysis, you need to calculate the VB. So the VB you can get by calculate the VR2. VR2 is R2 over R2 plus R1 times VCC. So this one is the voltage divider rule. So this is the voltage divider rule. And then once you get the VB, you can calculate the VE. So VE is VB minus VBE. Although in approximate analysis, we assume that VBE is equals to 0 volts. Okay. However, during analysis, during calculation, okay, you cannot put 0 volt here. You need to minus 0.7 volts. E is 0.7 volts. So VE is equals to VB minus VBE. Whatever value VB you obtain in here, you replace it and then minus with 0.7 volts. From VE, okay, you can get the IE. Okay, so how to get IE? IE is VE over RE. Maybe I need to write down so that you will not get confused. Okay, I already add another equation here. This one's supposed to be number 4 and 5. Okay. So the third formula is to calculate IE. So IE you can get from VE over RE. Whatever RE value here, you just put it, replace it, and then calculate the value to obtain IE. And then next formula is IC is approximate to IE, and IB is IE over beta plus 1, or you have another one, IC equals to beta IB. So you can also use that formula as well, right? Analysis, beta RE must less than 10R2. Use Thevenin method at input loop. Okay, so you need to find the VTH and RTH in order to calculate the IB. So the IB formula is VTH minus VBE over RTH plus beta plus 1 RE. How I get this formula is via KVL. So you need to find VTH and RTH to calculate IB, to obtain IB. But to get IB, you need to apply KVL first. Once you get the VTH and RTH value, so again, this is the formula IB. You can get it from the KVL equation. Again, KVL at output loop, you will get VCE and VCLN. Okay. Number 2. So we have region, cut-off region. We know that we have cut-off region, saturation region, and active region. So in BJT, if the E junction is in reverse bias as well as in CB junction, the BJT is in off mode. For saturation region, both must be in forward bias. So the BJT is on mode. So the on and off mode, right? We can use the BJT as a switching circuit. However, in active region, both one must be in fault bias, which is in BE junction, whereas another one, CB junction, is in reverse bias. Application that the BJT can do is to be as an amplifier circuit. Alright? Okay, now we can proceed with next lecture, which is BJT AC analysis. Usually in final question for BJT, we combine the DC and AC analysis in one question. Right?